Alright, so today we're going to be looking at limits involving infinity. Just have a couple of quick notes at the top. A 0 divided by a number is just 0. A number divided by 0 is undefined or does not exist. A number divided by infinity is 0. And infinity divided by some number is just going to be infinity. The first thing we're going to do is we're going to look at the function 1 over x minus 2. And we want to look at this as x is approaching 2 from the left. So we're going to take the limit of our function. Now graphically it will help us to see this. Okay, let's see if we can get a graph of this. Roughly this is our function 1 over x minus 2. If we approach 2 from the left, okay, what is our value approaching? What's the limit approaching? Negative infinity. Good. Let's keep that in mind because algebraically we're going to do it. It's a lot easier for us to wrap our head around this graphically for whatever reason, especially for visual. What about if we're approaching 2 from the right? Positive infinity. So what about our limit in general as x approaches 2? Does not exist. So we're under the assumption by just being able to put in our graphing calculator and look at this to say we think that it does not exist. But let's work this in an algebraic sense. If we take a number to the left of 2, something that's really small, very small number to the left of 2, what about that? What would that give us? If we were to plug in just 2, what's 2 minus 2 on the bottom? Right? It's technically going to be 0, but something that's a very small negative number close to 0. A very small negative number close to 0. So I'll kind of make myself a note that 2 minus 2 is be 0 because I know I'm going to be very precise. The more precise I want to guess that number, it's going to be a very small negative number close to 0. But what happens when we get 1 over 0? A number over 0. You're going to get infinity, and then we have a positive divided by a negative, which is a negative. And that does verify what we had in our graph when we looked at it graphically. Okay. Alright, now if we pick a number just to the right of 2, and we want to be precise, that would give us a number over something very close to 0, but what about the sign? Positive. Yeah, so our notation, our little reminder to us, and that's just how I like to denote it, it's going to be something very, very close to 0, but it's going to be positive. So a number over 0 is going to be infinity, and what about a positive divided by a positive? Is a positive, right? And then so if our left hand limit is negative infinity and our right hand limit is positive infinity, then what do we know as x approaches 2? Does not exist. Okay, sometimes the text will give your function, present the problem in this way, gives you your function, tells you a value for a, and asks you to find a left hand limit, a right hand limit, and the limit as x approaches a. And of course, you'll just substitute -1 in there. So we're going to approach -1 from the left, -1 from the right, and the function as it approaches -1. So I'm going to go graph this so we can visually look at it. Okay, so if we look at this graphically, let's approach our a value, which in this case is -1. So we're approaching the x value of -1. Let me just put my arrow there. As I approach -1 from the left, what happens? -1 from the left, where are we? Positive infinity. What about if I approach -1 from the right? Negative infinity. So what about the function as we approach a function of just -1? Does not exist, right? Okay, so let's algebraically verify that. If I plug in -1, I'm going to go to the left of -1. What's a number that's to the left of -1? Like -1.1? Okay, so if you were to plug that in, okay, so we have the option to choose any number. Of course, we want to choose a number very, very, very close to -1, but to the left of it. Of course, this isn't very close, but enough to see the idea. If I plug this in, a negative number squared is just going to be a positive. and we'll have a positive number in the top. Now on the bottom, if I were to plug in -1, let's just look at -1 specifically. -1 squared is just +1, minus a -1 will be +1, so that would just give us 2. 1 plus 1 is 2 minus 2, so we know we're going to have a number close to 0 in the bottom. So here my notation will be 0 in the bottom, but really I need to know will it be a positive or a negative value there. So if we looked at -1.1, it's clearly going to be a positive value in the denominator. So what is a number divided by 0? Infinity. And what about a positive divided by a positive is just going to give us positive infinity. Okay. In likeness, we're going to say as x approaches -1 from the right. So on a number line, a value that's close, very close to -1, but to the right of it would be, let's say, like -0.9. Let's just say -0.9. If I had 2 times a -0.9 squared, what kind of value will we get in the top? Just some number, right? Okay. And if I had -1, I'm going to get something that's very close to 0, but will it be positive or will it be negative? It's going to be a negative value. So in this case, it's a number divided by something, a very small number that's negative, very small number close to 0 that's negative. We would just get infinity, and then a positive divided by a negative is a negative. And of course, if our left-hand limit and our right-hand limit do not match, then the limit as x approaches a does not exist. Okay, so let's look at another example of this. Okay, real quick, because we had some questions about the last one. If you need to see concrete values for part A, if we just identify in the denominator, that value ended up coming up to 0.31, which all we care about is it's a number close to 0 that it's positive. So that's what we did here. When we looked at -1 from the right, we picked the value to the right of -1, which over here you could see, and you simplify it, and we get some value that's going to be close to 0 but negative. Now when we say close to 0, we know that the more precise our guess is of this number that's close to -1 from the left, the more precise we will get in general, but it suffices to be able to do that. In our next example, we're going to have our function is given as -1 over x plus 1 squared. As x approaches -1, we're going to approach that from the left, from the right, and as x approaches -1. Graphically, it's really easy to tell. Let's approach -1 from the left. What about it? As x approaches -1 from the left, negative infinity. X approaches -1 from the right, negative infinity. So thus the limit as x approaches -1, we would say negative infinity, but we know that the limit equals negative infinity does not exist in general, okay, because it's unbounded, but we do know something about the function's behavior at that point. Okay, let's algebraically verify that. First of all, if I plug in, what about my number in the top? Just going to have a negative number, right? I just have actually -1 to be precise. But pick a number to the left of -1, just to the left of -1. Let's just say -1.1. If you just throw that out there, what happens? -1.1 plus 1. Negative something, but what is a negative number squared? Positive. So really it's just going to be something's close to 0. We don't really care what. It's to be more precise, we can choose whatever we want. But what happens when you get a number divided by 0? Infinity, right? But then what's a negative divided by a positive? A negative. Good. So it tells us our behavior at that particular case. It's headed towards negative infinity. All right, and the same thing in B. We're going to have number 1, -1 in the numerator. And let's choose a number to the right of -1, so like the last one. -0.9. If we plug that in and we add 1, it doesn't really matter because what a number squared is still going to be positive. So in this case, a number very close to 0, but it's positive. A number divided by 0 is infinity, and then we have a negative divided by a positive is a negative. What And because our left hand limit and our right hand limit, so we know it's approaching negative infinity, therefore it does not exist.